Okay, so let's go over the sample of the chain rule. Okay, the first one. Okay, so I have function f of x equal to square root of 1 plus x squared over x. Now, if I want to take the derivative of this function, or I want to find f prime, you have to know that this is a quotient, right? So we need to apply the quotient rule. So I call the function on the top to be f1, the function on the bottom to be f2. Now, what is the rule for the quotient? The rule for the quotient saying that the derivative of the quotient equal to the derivative of f1, f prime of 1, the top multiplied by the bottom, subtract the derivative of the bottom, f2 prime, multiplying the top function, and over the bottom square. So what about the function in the bottom? You square that whole thing. Now, we already know f1, f2, right? But we don't know f prime of 1, f prime of 2. So let's first find these two guys, and then we can plug in this whole quotient rule. Now, f1, I have what? I have square root of 1 plus x squared. So how do I find f1 prime? Okay, take a look at this function. If you look at this function, we know that normally you know how to take the square root, right? You know how to take the derivative of the square root of x. If I have this is f of x, we know how to do this. This is easy. This is the basic function. This is gonna be 1/2 for the square root, right? If you take f prime up here, you're gonna bring the 1/2 down, and then you subtract 1 from 1/2, which is you got minus 1/2. So we know how to take the derivative of, we have the square root of x, but not the square root of 1 plus x squared. This thing inside here messed up everything. So the thing is, you have to apply the chain rule. So what I do is I call u to be whatever inside function here, 1 plus x squared. Now what I have is what? Square root of u, right? And then if I take the derivative of this one, this is easy. This is what? This is the same thing here, right? I have u to the 1/2, and if you take the 1/2, you can bring down the 1/2, and then you subtract 1 from that, so minus 1/2. But don't forget that because we borrow u to be this guy, you have to multiply by the chain rule. You have to multiply by u prime. That's what that means. You are trying to multiply this thing by one more derivative of u. Okay, so what is the derivative of u? We can find here u prime equal to what? Constant 1 is becomes 0. 2x, bring down the 2, subtract 1 from that, so you have 2x to the 1 power. Okay, so I have everything here. U, which is 1 plus x squared. I call that 1 plus x squared. So I can write that back. 1 plus x squared, that's for u, and to the minus 1/2. U prime is what? It's 2x. Now I can cancel the 2. I have what? I have just x multiplied by 1 plus x squared to the minus 1/2. Right? That's pretty easy. So we got f1 prime. Now the only thing we need is f2 prime. Now f2 is x, right? We know f2 is x, which is x to the 1. So f2 prime, use the power rule, bring the 1 down and then subtract 1 from this. So you have 1 multiplied with what? X. 1 subtract 1 is 0. X to the 0 is 1. So the whole thing just be 1. Now we have everything. You can plug into this quotient rule. So I'm going to do here f1 prime is what we got here, 1 plus x squared to the minus 1/2. f2 is x, right, minus f2 prime just 1. Multiply by f1, which is the square root of what? 1 plus x squared. The whole thing over f2, which is x, and then square. Okay, so that would be your solution. You can combine x and x become x squared, right? So that's for x squared here, you write that, and that's what should be your answer. So apply the quotient rule to this quotient, but don't forget that we have to apply the chain rule, because we know how to take the derivative of the basic function square root of x, but not the square root of 1 plus x squared. So we have to solve u to the inside function to make it become the basic function first before we can move on. Okay, so that is the first problem. The second problem I have here is f of x is x and e to the minus 5x. Again, the same thing here. We have multiplication, so I call this one is f1, this is f2. So what is the rule for the product? The rule for the product saying that if I want to take the f prime of this function, I take the derivative of the first function, or f1 prime, then I multiply by the second function, then I add to the derivative of the second function, then I multiply by the first function. So this is the rule. We have f1, we have f2, so we only need to find f1 prime and f2 prime. Then we can plug into this formula, then we are done. Now f1 is x, which is x to the 1, so f1 prime, use the power rule, bring down a 1, subtract 1 from this, 1 minus 1, that gives me 1x to the 0, which is to the 0 power is just 1, we have only 1 by the end. Now f2 is what? E to the minus 5x. Now we need to take f prime of 2 equal what? The thing is, now we got stuck here. Normally, if you have f of x equal e to the x, then we know how to take the derivative of this function, which is the same thing, right? E to the x, we take the derivative, you still got e to the x. That's the rule. But now we don't have e to the x, but we have e to the minus 5x. So in order to make this function to become similar to this one, I call this whole thing here to be u. Okay, so now my f2 is going to be what? E to the u. Now e to the u, the same thing here. I can take the derivative of this one, which is what? The same thing. E to the u is just e to the u. But don't forget that we have to multiply by what? By u prime, or one more derivative of the u, because we borrow that. We need to take one more derivative of u. And u is what? Minus 5x, x to the 1 here. So u prime, use the power rule, bring down a 1, so minus 5 times 1, still minus 5. X to what? X to 1 minus 1, and x to the 0, which is 1. So you have minus 5. So here we have what? E to the u is what? U is minus 5x, right? So e to the minus 5x, and u prime we already found minus 1, minus 5, and you can simplify it to be minus 5 e to the minus 5x. Now I have f2 prime, f1 prime, then I can plug in this formula. So f1 prime is what? Is just 1, right? f2 is just this guy. f2 prime is what? This guy. And then f1 just x, right? So I can simplify this more. This is e to the minus 5x, this is minus 5 e to the minus 5x, and multiply with x. So that should be your answer. Straightforward. You apply the product rule, but then inside the product rule we need to apply the chain rule if we need to. Okay, if you watched up to this point, I give you one point extra credit. You don't have to do this on Wednesday. just email me before the class on Wednesday, saying that you watched the video on the sample on the chain rule, and I'll give you 1 point on these 3 problems. You don't have to submit to me anything, just watch the video and email it to me. Now the last problem, what did we have for the last problem? The last problem, I have f of x to be 5x plus 1 to the minus 5 and x squared. So here we have what? Again, there's a multiplication here. So I have, this is f1, this is f2. So again, this is you have to use something called a product rule, right? Because this is multiplication. Now the product rule say that if you take the derivative of f, you take the first derivative and multiply by the second function, and you add to the derivative of the second function, multiply by the first one. We have f1, f2 already, but we don't have f1 prime and f2 prime. So let's find that and then plug in this formula. So f1, I have what? I have 5x plus 1 to the minus 5. Remember, this looks like something we can apply the power rule, because there's a power here, right? But inside here must be a single variable, or the x. We already know how to take the derivative of x to the minus 5, right? Just bring down the minus 5 and then subtract 1 from this. But in here we don't have x, we have some other stuff. So why don't I call the whole thing to be u, right? So now f1 become what? U to the minus 5. Make sense? Yes. Now from here we can use the chain rule, right? But first apply the power rule. If I take f1 prime, I can bring down the minus 5, subtract 1 from this, so minus 5 minus 1 give me minus 6. But because we borrow u, you have to multiply by u prime, right? The derivative of u. Now u is what? U is 5x plus 1. So u prime, this is 1. So bring down the 1. 1 times 5 is 5. And then x to the 1 minus 1, which is x to the 0, which is 1. And the derivative of 1 is just 0 for constant. So u prime is 5. So now you can plug it back in here. Minus 5, u is what? 5x plus 1. Minus 6, and u prime is what? It's 5. And now 5 and 5 give me what? Give me minus 25, right? And then this whole thing to minus 6. So this one is f1 prime. What about f2? f2 is easy. We have the power of x, so f2 prime is what? I bring down a 2, right? I subtract 1 from that. 2 minus 1 is just 1, or 2x. Now I have f2 prime, f1 prime. I can plug into this formula. f1 prime is what? This guy here. So minus 25, 5x plus 1 to the minus 6. f2 is what? X squared. And f2 prime is 2x. And then f1, this whole thing again. Okay? Now I can do some simplification. So bring the x to the front. I have minus 25x, 5x plus 1 to the minus 6. And this is, I have 2x, 5x plus 1 to the minus 5th. So this should be your answer. Okay? So easy. Use the product rule, but inside the product rule, use the chain rule. Now there's one trick question on the midterm that a lot of you guys, no one got the correct answer. I give you a function something like 10,000 plus e to the minus 1. And I ask you to take the f prime. Okay. Now I want you to take the derivative of this function. But remember, this is 10,000. E to the minus 1 is what? E to the minus 1 is basically just 1 over e, right? We can bring it down to the bottom. Now e is just a single number, 2.71 1828. So you have what? 1 over 2.71828. This equals to some constant, some number, right? Some number add to 10,000, still some number. So this is just a single number. You take the derivative of a single number, it gives you 0, because you take the derivative of a constant, it gives you 0. So without the calculation, you can just say it equal to 0, because all of these are actually just the constant, nothing complicated. Now another problem is 1 over x. If I give you this function, right? Now 1 over x, if you convert it back, you can rewrite it as x to the minus 1, negative exponent. Now use the power rule, bring down the minus 1 and then subtract 1 from this. So minus 1, x minus 1 minus 1 minus 2. So this should be your answer. Pretty straightforward and easy. Okay, one more example for the chain rule and we should be good to go. Now I have this function. Okay, so how do I solve this function? Remember, if I want to take f prime, how do I do this? We have the square root. Okay, remember before, I can take the derivative of the square root of x, right? This is easy. This is just x to the 1/2. If I take the derivative of this one, I just bring the 1/2 down and then subtract 1 from that, which is minus 1/2. This is simple. It's really simple if I have the x inside. But now, I don't have the x, but I have e to the x. That's messed up everything. So the one that messed you up, you call that equal u. Okay? So now, I have what? I have square root of u. And I take this derivative. Now, square root of u, the same thing to this guy. Nothing is new. You have u to the 1/2, right? And then you take the normal derivative. Bring the 1/2 down, subtract 1 from this. So 1/2 minus 1 is equal u to the minus 1/2. But don't forget, because we borrow a u from this guy, you need to multiply at the end by u prime. Okay? That means we take one more derivative of u. Now, u is e to the x. So, u prime, e to the x is derivative, it's the same thing. So, nothing is changing. You take the derivative of e to the x, it's still e to the x, right? So, now we can get back the x. So, u is what? E to the x. I can rewrite that, and then to the minus 1/2. And then u prime, it's just e to the x. Okay, if I simplify this, this is e to the minus 1/2 x, this is e to the 1x. If you add the two exponents together, you got e to the 1/2 x, and don't forget the 1/2 on the front. So that is how you apply the chain rule to this particular function. Okay, hope this makes sense, and if you do have any question, email me or bring any question to the class on Wednesday.